Hello everyone. We look into alloy composition problem. There are two scraps A and B, with percentage composition of aluminum, silicon and carbon. The scraps are to be mixed in proportion of tonnage to obtain final alloy mixture. The total alloy tonnage requirement is 1000 tons. The cost of two scrap are $180 per ton respectively. Further, the final alloy mix has a range of composition for aluminum, silicon and carbon denoted by minimum and maximum percentage requirement. Pulp and Pandas packages on operations research solver and data manipulation in Python are loaded. All the data is loaded. The problem consists of two scraps which are processed to produce an alloy. Alongside we load data in list form and convert them to data frames with indexing. Amount is parameter on tonnage of alloy to be produced. Cost, composition, minimum composition and maximum composition are four data frames loaded for model. The notations for alloy composition problem consists of indices I and J for scrap and metals. I and J index belong to set S for scrap and set M for metal. The parameters are inclusive of data frames used in the model. These are cost, composition, minimum composition and maximum composition. Decision variable X is tons of scrap for each index I used in final alloy composition of 1000 tons. X is a continuous variable. The formulation of alloy composition problem is illustrated in mathematical form. First we have the objective function for minimizing cost of scrap amount. The first constraint is minimum metal proportion requirement. The second constraint is maximum metal proportion requirement. And third constraint is alloy amount requirement. We create a class alloy composition. Initialize the class with the method and feed the data and data frames to it instantly. Next, we define the problem self.prob for minimizing the total cost. Next we declare continuous variable self.x for amount of scrap used in processing of alloy. After declaring the variable's objective function is defined. The objective function is prepared by summing up cost of scrap multiplied with amount of scrap used self.x. The three constraints in mathematical form are then enumerated. The first constraint is minimum metal proportion requirement. The second constraint is maximum metal proportion requirement. And third constraint is alloy amount requirement of 1000 tons. The formulated problem is then invoked for solving with solve method. Please note we also write a .lp file, which is a good way of checking accuracy of model with data. Other methods are for getting the status, objective value and variables value as usual. Finally the formulated model is solved to analyze the result. The optimal alloy composition requires using 333 tons of scrap A and 667 tons of scrap B for producing 1000 tons of alloy. The code for the problem in this tutorial and previous tutorial are shared publicly on GitHub. The links are under the respective videos. Thank you for watching the video and please subscribe to the channel.